Hello friends, this is my third part of the enzyme video, and if this is my website easyscience.com, you can always visit for new videos. This is my YouTube channel link. You can always see the videos and can leave comment, and please subscribe my channel. If you have any further question or if you have any suggestion, you can always write to me at mukhop 89 at the rate of gmail.com. This is my website. This is mukhop, mukhop. So now let's go to the next slide. The thing is that we were talking about this Michaels-Menten equation, where it states that the small v is equal to v max s by km plus s, and we have already talked about this km shows the affinity of the substrate, but at the same time km also gives indication of the substrate concentration. Now it clearly states that if the substrate concentration is equal to km, then the small v is equal to v max by 2. So we will be discussing three conditions, and what happens to this equation and what we can predict from it, we will see that. So here in the first case I am saying that km is equal to the concentration of the substrate. So now if I put the values over here, I am putting this value that small v is equal to v max into s by km. In this place, in place of this km, I am putting the value of km, which is s. So the condition is like this. Now small v is v max s by 2s. You cancel this to s. Now you can always write this v is equal to v max by 2. So here we can straight away understand that km also gives a hint on the substrate concentration. If the substrate concentration and km concentration is equal, the velocity of the enzyme will be half of the maximum velocity. Now let's go to the next condition, where this substrate concentration is very less than the km. The equation was v is equal to v max s by km plus s. Now the thing is that when you are adding up this s with this km, you can always ignore this part, but you cannot ignore because it is multiplied with the v max, but you can always ignore this part. And if you ignore this part, you can write that v is equal to v max by km into the substrate concentration. Now this v max is very much constant for a particular enzyme of at its given concentration in a particular reaction, and this km itself is a constant. So you can write that this is the constant and this is the substrate concentration. Now this v is directly proportional with the s, and this is a first order reaction. And you can always say that in a very lower concentration of substrate, the velocity of the reaction always increases according to the substrate concentration. If you increase the substrate concentration, the velocity will increase. So the relation is a direct proportion, is under the control of direct proportion, and here the substrate concentration is playing a role in deciding the velocity of the enzyme. Now the last condition is this. This is the third condition. The last condition is this, where the concentration of the substrate is far more than Km. In that case, write down the equation, that is V is equal to V max into S by Km plus S. And here in this case you can always ignore this Km, because it is the concentration of the substrate is far greater than this Km. So Km is so small part, you can always ignore this, and you can write that V max into the substrate concentration by this substrate concentration. You have already ignored this part. You can always cross this substrate concentration as well. So here the V is equal to V max. Now here one thing you can get a conclusion, that the velocity of the enzyme has already reached the maximum velocity, so there is no chance of increasing the reaction rate any further, even if you increase the substrate concentration. Here the reaction rate is not now not dependent on the substrate concentration, and this is a very good point. This is called a zero order reaction, where you are not really bothered about what is the concentration of the substrate now anymore, and the reaction will take place on its own way, not depending on the substrate concentration.